Alright, hopefully
Welcome back.
everyone is full, happy, ready to go.
No full in the sleep, okay? So do you guys have fun with the exercises a little bit? I mean, I actually have to say, going around, I was impressed, very much impressed by the pace that you were checking out the exercises and getting to the open questions. Now, admittedly, the open questions that you were thinking about toward the very end, you could spend a week on them probably, or at least a day, to come up with the right questions. Because the funny thing is, often with data, you don't know what the right question is, and you just have to revise your understanding and your questions about the data as you go. But that said, there is an answer to those questions, and there is a universal relationship between x and y that you could potentially figure out. And once you can do that, then you can figure out all the other questions as well, kind of at the same time. The reason why they ask separately is because I wanted you to think about how all those things come together into the observation. So you cannot really answer one question without answering the other. Okay? So you can't answer which one is the best instrument without thinking about how the students differ from each other, because some students might make really bad measurements with a good instrument, and so on and so on. Right, so that's the kind of thing that, or maybe a run could be bad. We used to do holograms in the lab, and every time the subway went by, the hologram would be destroyed. Right? So we had to actually have a pretty good understanding when the subways come, and because it's such small changes in the optics. All right, so what we are going to do is move on. You're welcome to come back to these problems later on. In fact, we'll have another long exercise for you, or a long session to practice your skills. You're welcome to come back to these questions, or move on and play with the new problems. I want to show you first a couple of interesting constructs that are useful to have. Move on to data management and programming. All right, so let's see. So this one is up. You consider the problem. Who are the two busiest users? Now, again, intentionally, I was vague with that question. You can think of it as who made the most number of measurements, or you can think of it as who had the most number of runs. It may or may not be the same thing, right? So these are the kind of subtleties that you have to consider when you translate an English question to a SQL question. And in fact, in the process, you actually learn a lot about the data and the subtleties of the data. So whichever this definition you pick is fine with me. Here is one solution that you might have done. This is using joins. Okay, maybe I made it a little too big now. Is this readable for you? And make it this small. Is it good? So what's happening here? You are saying, okay, let's query the data table, right, and count the number of data points. Okay, but I want to group by the users, so I have to join that with the runs table. So we're doing essentially a query on the runs and the data tables, joined in the run ID, group by user ID, that's what we care about, and only pick the descending order, the largest group by, order by 2, the second column, like 1, 2, right? Or pick the one that has the most number of measurements. Okay. But that's an inner query, a nested query, right? And so when we go back and use the user ID to join that with the user table and pick out the username like that. Another way would be to actually join in the user table right away. So I've seen both solutions, and this is the one maybe that was used less or least frequently. But you could just join into this join the username as well, and then you can just you just have to be careful how you do the grouping, and that's all, right? So I want to show you now. Yes,
so
yes.
What's the letter B doing there?
Oh, right. So remember that the nested query is kind of giving you a result set, a table, that I have to refer to somehow, right? So because I'm joining it with the users table, so there's a users table U, and there's something that's unnamed until I give it an alias. The B is how I refer to this result set.
Oh, okay.
Okay, in this join. It's a very good question. I'm glad. I can't show you everything in a systematic way, but I try to show everything on the screen, and these questions help me too.
So you could have put as B or?
Yes, that's right. In fact, that would have been probably a nicer way to do it. Yes, that's as B. So that's the B is the alias of that result set as B. Just like here, this is as B, for example. Okay. So, right. Now, of course, I forgot already, but I was going to do. I was doing all these things in a separate window. Remote desktop. I'm just logging quickly into that machine that we were using before. Username, password. Okay. So I want to write this query again in a different way to introduce a new construct that's called common table expressions, CTEs. This is something that's very useful, very powerful, and makes the queries very, very readable. So here, if I put this here, oh, I'm sorry, wrong window, this one. There we go. So this is the same query we had before. If I run this, I have the top two users. Okay. Now, if I go back and I do nothing else but take out the inner part of the query, which is something that you can run separately, right? I can name it something in front of the whole business, and the way to do it is this whole common table expression stuff. There we go. So here's the query that is selecting the top two users. I can run this, right? It gives me user ID and counts. I'm going to call this busy users, and this with statement is defining the common table expression. So with busy users, these are the column names that I'll be using, user ID and N, and here whatever I put here, that query will define what that thing is up there. Okay, this is CTE. And then in the rest of the query, I can just refer to it as if it were a table. Okay, so busy users is not a table. I could create one, but it's not a table right now. But it's defined to be a common table expression so that I can refer to it as if it were a table. Okay, it's just syntax. But it's very nice because now the nested query that you always have to start, that's interesting. So there's no power in this.
There is, I'll help you out. Okay,
thanks. So because I always start with reading that nested query first, we may as well break it out and put it in front and name it something so I can refer to it later in the query. And that's what happens here. We take that nested query out and just name it something. And then later on, our query under this sign becomes very simple. Let me just close this one. Becomes very simple because now I just say, I just use the users table and join it with this thing, and that's it.
So for the stuff in parentheses by the with statement and busy users, does that automatically alias to whatever's in your select statement? So for example, you have a user ID, but you have in, and there's no count as in?
Yeah, exactly. So it's optional. I could omit this, but then I have to make sure that everything is named here, or I can use the names here, and then you don't have to, and then you can't have anything. So I could have called this UID as opposed to user ID, and then I would have to refer to it here like that. So here you have a chance of renaming and naming everything, and again, just a nice way of having everything in one place, the name and the column names. Right. And it checks. So if you have 3 things selected, but you only name 2, then it will say, hey, there's something wrong with your CTE. Okay. This is very powerful. And this is actually a very fancy construct that you can use for other things. You can actually write recursive CTEs. Who knows recursion? Who knows recursion? Yeah, okay, so the joke is to know recursion, first you have to know recursion. Yes, I know. Right, so let me just show you one example for that, and the exercise will have some more for you to think about. Here's a very simple one, to create a common table expression that simply counts from 1 up to 10. Okay? So here you're defining a CTE called N. It has a single column I. And the way we define it is that we select a number 1. And then the union all that, union all is the set operation, not unlike union, it actually just concatenates things. It doesn't think, it just concatenates things. It unions that set with another set that is selecting from N itself. Right? We're selecting N plus 1. See what happens? So, and this is a way to, and then you can just say in the end, actually select I from N. So if I run this, you see what happens. This is actually something that was used in the generation of the data that you were using. It just counts from 1 to N, or 1 to 10. Right? So this is the limit that limits that. If I change this, it will go to a different number. So you can use this to do all sorts of fancy stuff. You can calculate the Fibonacci series. You can anything that's recursive. You can walk a graph, right? So if you have in a database nodes, what's an example? So say you had, if you had a family tree, right, and you have people, and then you have the relationships. You could use this technique to walk the graph and find relatives and things like that that satisfy certain constraints. Okay. So anyway, so CTs are very powerful and very elegant, very easy to read a code that is using them, and we'll be using them later on a little bit. So, just to give you a very quick one, here's the Fibonacci series, just for kicks. All right, so F is the name of that, right? And the Fibonacci series, for those of you who don't know, it just formed the next element by adding the previous two. Okay, so first two elements are 1 and 1, or whatever it is. It can be anything really. And then the next one is the sum of those two, and then the next one is the sum of the previous two, and then so on, so on, so on. Has some interesting properties in math. But this is just that. You're starting with essentially the first element and the second element. You just form, take the last element and the sum, and then you just recurse like that. Very simple. And then in the very end, is interesting as well, just to mention. There's a bit of conversion here. These are integer numbers, right? If I run the division between two integers, you get 0 or something. It gets truncated, rounded. So instead, we convert them both to floats before we do the division, and this is just a way to estimate the golden ratio. So I don't know if you know what the golden ratio is. This ratio is estimating the golden ratio, and that's that. Anyway, it's just for those who know and appreciate that mathematical fun. Okay. So that was the busy users. That was the CTEs. Nice tool. Use it if you want to. If you don't want to, don't use it. Right? If you are using SQLite and it doesn't support CTEs, don't blame me. Okay. If you're using something else, don't write me an nasty email that you're using a tool that doesn't support fancy stuff. There's always other ways of doing it. Right? You can nest things. There's always other things to do. Maybe less elegant. Okay, so let's move on and talk about data management. And what I was thinking is that we can go through all the elements of data management by creating essentially a simple grading system for the students that we have in this lab. Okay, the users that we're making the measurements could be graded. Maybe we have a table for the grades that has essentially what letter corresponds to what score level, and we have another table where the scores go in for problems and exams, and we just write a query that essentially figures out for everybody what the score is. Okay, so this is going to be a sort of a little exercise, and as we go through it, we talk about all the relevant bits of creating tables, of populating tables, and using these. All right, so the first thing which is new, and not a select from there, is the create table command, which just essentially defines an empty table. Okay? So here we go. Create table grades. All right, so I want to talk about everything that's in here before moving on. It's a very short, small piece of code, but let's make sure everybody understands what these things are. So grades is the name of the table, and it has 3 columns. Okay? The grade ID, just a good thing to have an identifier. It is a tiny int, it's just the type, what type it is. It just means it's integer, it's a small 1 byte integer, I think. And what are the other things? So not null, it's very important. So in databases by default, every column is nullable, which means that you don't have to put a value in it. You can leave it null. There's a number of consequences. This is not something you will find in Sloan, for example, because the convention is not to have nullable columns, partly because it's a penalty for performance. It's essentially extra bit to store per quantity, right? And if you have 500 quantities, it's a lot of extra bits to store. But also, it's a performance hit when you do operations, because first you have to look at that bit before looking at the value itself. So I'm defining this to be not nullable. It means that that value has to be there. If there's a row in this table, that value has to be there. This grade ID will have to be there, and so does the grade. The grade has to be there. There's the letter. It's a varchar2, meaning it's 2-character variable length string. Could be F, D, E, A, or A plus, or A minus, C plus, whatever we want to come up with, right? That's why it's 2, so the plus and minus can go in there. And it's not null, it has to be there. It cannot be an entry that has a null in that place. All right, so let's keep on going. The identity 1-to-1, that's just a convenience thing. It means that I don't actually have to insert this ID. It will get automatically put in for me. Starting with a 1, every time I insert a new value, it will add 1 more to it. So the first insert, the first time I put in something, it will be grade 1, grade ID 1. Second time it will be grade ID 2, and so on and so on. Okay, so that's that part, just a convenience thing. The database will automatically take care of all this numbering for me. Okay, and it's good because I can refer to it later on. I can just say this is the entry, as opposed to saying everything else. The primary key is what tells the database what to sort on. Okay, how to lay down this data on disk. Okay. So, for example, in Sloan or any other SRAM database, there will be an object ID that identifies the source, and that object ID is the primary key typically. Okay, and there's reason for that being the primary key. It's formed usually such that things close on the sky will be close to it in object ID space. Hence, it will be close to each other on disk as well. So you usually use data from same part of the sky together with other data from the same part of the sky, as opposed to just random stuff around, which would be a long access time if you have to go there and fetch it, as opposed to just reading through. Anyway, that's performance optimization. So that's primary key. This is the key that is unique and the data is clustered on. And if you want to look up something based on this, it's very fast. So you can have 500 million entries in this table. As long as the primary key, the primary key column, you can do a lookup on that very fast. You can do a join on that very fast. So run ID, user ID, ID in the data table, everything is a primary key, so that you can do very quick joins. And you can have foreign keys. So in the runs table, it's run ID, but in the data table, there's also a run ID to make the link, right? The queries you were building. The run ID in that database would be a foreign key, so that it have a constraint. But that's detail. So that's primary key. So we are done with the first row. Okay. The second row is kind of done as well. Not null, unique. That's obvious, right? You cannot have 2 entries in this table that have the same grade. you cannot have 2 entries with A+, because I want to set up the scoring. So this table is going to contain the score limits, and not just that, right, the integer. So it says, you know, if the total number of score points you can earn in a semester is 100, then maybe 15 is, or I don't know, 50 is fail, 60 is, I don't know, C, 70 is B, and so on, right? Whatever. This is what this table is going to contain. Okay, this is just the schema for it. It's called a schema, the table schema. This is what defines the empty table. Okay. Any questions about primary keys? Any of these things? Good. So let's create this empty table. All right. Let's get some grades. Excellent. Thank you very much. Somebody else has already created this table, right? So I can't run it because somebody beat me to it. Okay, that's fine. Whoever was, I just hope that you did the same thing, and not something else. But if you did, you know, we'll find that quickly. All right. So the next thing to do is to put some data in this table. Right? So actually, let's see what's in this table right now. I'm going to be lazy and use the wildcard. Let's do select star from grades. Okay. So there's grade ID, grade and score limit. There's nothing in this table. Okay. If you beat me to it before, now you can beat me to it again. Let's put in some entries, right? So let's put in some score limits for A, A+, C, D, and so on. Okay. Is this I think it's E? Probably not. But yes, let's just put in some values. One way, these are all, of course, in your write-up. So if you read ahead, then you can cheat. But here is a couple of ways to enter values. You insert into grades. You specify the columns in which you're inserting, and then the values you're inserting. The reason why there's no grade ID, again, because it will be done automatically for you, right? So if I run this, I get a bunch of errors. Why? Because somebody has beat me to it, right? And it says, well, no, I did something wrong. Oh, I'm okay, looking at the wrong window. Apologize. There we go. Awesome. So they actually completed. I inserted 2 rows, one row in the first query, one row in the second query. That's a little small read. I apologize. Let's see if I can fix this. Tools, options, fonts. What is this? Text editor.
There's size to it, right?
Text results. Like that. Okay, I'm not going to restart the application for this. Okay. So now if I go back and run this select statement, I will see these entries. So I have my F and my A+ inserted. And let's insert some more. Actually, there's a point that you guys didn't beat me to it and didn't put in more values already. But let's just put in some more. And again, here there could be some subtle differences between different versions of the databases. The SQL Server supports multiple inserts in one go. You can do just like this. And I put in 4 rows. And if I go back again to run this, I have a bunch of scores. Okay. And then just a table that you can query the same way you queried before. If I were to just make sure everything is in order, I can order by the score limit and see that A plus A minus B, C, F are nicely lined up. So it's ordered by score limit descending order. Looks good. Okay. So we are done with the grading. So the grading table is set up. This is, you do it in the beginning of the semester, and after that, you do the work, and then comes the exam. And the exam has to be captured somewhere, and we have a table for that. So let's create an exam table. Okay. And just another create table statement, right? So you have a user ID is not null. It could be a foreign key. Let's not worry about that just yet. And there's a problem. We have problems on every exam between 1 to 3. And then we have a score. That's how many points they got. And then there's a composite primary key on this table. Okay, so what does that mean? User ID is clearly not unique, right? Because there's multiple entries for each user in this table. And in fact, the problem is not unique either because there is multiple problems that the user solve. The two together is unique. So every user, every student should just have one problem of each, right? So one score for each problem. So that's why this primary key is essentially doing two things for us. One is enforcing the uniqueness of the user ID problem combination, and it's helping us to do quick searches on user ID and problem if we have to. Okay. Not going to be a huge table. This is a nuisance, but if you're to do big tables, this is how you would think about it, right? Yeah.
If you delete a row from the table, like say a student dropped, will it reorder the primary keys, or are you stuck with your original ones?
It will, yes. It will do everything according to the rules of transactions, and I'll talk about this at the very end. But yes, everything will be consistent with the constraints that you put on the table for everyone that is running queries against this table, even concurrently. So you could be deleting something from this table while everybody else is inserting something else in this table, and I could be running a query against this table at the same time, and it will be consistent for everybody. Every constraint will be always obeyed. Okay? That's magic. Right. Well, yeah, it's a very good question. So okay, so now we have an exams table if we run this. Excellent, thank you. Somebody beat me to it. And what now I want to do is put in some scores. Okay, so I'd like you to do this. I'll put in a couple, but why don't you go ahead and insert a bunch of scores. So here, the first one is doing essentially insert into exams user ID 12, problem 1 gets 10 points, okay? And then the second variant of the same thing, user ID 12 on problem 2 gets 7. The reason why I don't have to write down this in the second line is because that's the order in which the schema was defined. If I have the columns values listed in the defined order, you don't have to write it out. If you shuffle it around, which you can, then you have to write out what you are inserting and in what order. Okay? And the into is something that you can omit at least in SQL Server. So if I run all these things, I get, okay, excellent. Somebody has already inserted stuff. So if I just run the exams, we have, oh, come on, do something else. Put in some more entries, right? So put in something for other users and whatnot. Okay, just go ahead. Because we'll be doing some more work on this. So just go ahead and just put some more entries in there. There you go. More. Come on, everybody put in just one, then we have a lot of entries. Okay. This is your first insert into a custom database that you just created, a custom table. Insert, go. Excellent, awesome, I love it. All right, good. So we have now a lot of inserts, and now let's start to look at it, right? So if I wanted to nuke everything in one go, I could just say truncate table exam. Right? That one command would just remove everything that you have done. Right? So you have to be careful with these commands. You can delete a table with a single command. Just say drop table photo, and then this whole 500 million row table is just like gone. Okay? You don't want that. Right? So usually the permissions are set up just right, and you don't have permission to do that. Yet, you have to be careful. In these databases, you can do anything you like. You can delete any table you like. You can truncate any table you like. So I ask you not to do it, just because it would take me 5 seconds to recreate it. But if you choose to, then you do it. Just don't do it every time. So all right. So now we have all these things in the database. So let's delete some, right? So first of all, if there's only 3 problems, then the problem entries should be all 1, 2, 3, and there shouldn't be any 4 or 5 or 100 or a million. I don't know what you put into those things. So the first thing I can do is I can delete all those things very easily, right? So let's delete all the entries from the exam table where the problem is more than 3. So just say delete exams where problem is larger than 3. I hit it, and there's 14 entries. So 14 entries had just stuff that doesn't make sense in this context. It's an error. It's a typo, administrative error. Somebody logged an exam point that was just not existent. There's no problem for. How about the users? Well, same thing with the users, right? So maybe there's no user IDs beyond 100. I don't know, I can't actually remember. But let's just try that. If user ID larger than 100, there's nothing like that, right? But you can just delete rows from yes.
So, is there any way of actually pulling out for like the distinct user IDs? Because if you look at the actual
Absolutely.
thing, so do you just do the like exact same thing, like where you delete?
Yes. So you can, right, so this actually, so you have to be careful with this, but you can do everything with the delete that you would do with a select, okay? So you can do a join, you can do everything like that. In fact, that's the next one. So what if I wanted to delete all the users from the exam table for which there is no matching entry in the users table? Okay, I can just do this. So from, again, you do it the way you do it with the select statement. You start with the from, right? So from exams, and let's call it E. You join that with the users table, right? Because you want to find out who the users are. And then you say, let's do a left join and look if it's not there, right? So for each exam, we look for a user. If there's no such user, it becomes, the name becomes null. So if the name is null, then that's a user that for which there is no matching user. Does that make sense? So if you forget about the delete part, right, then it's a query that you have written before. The from exams left join users on the user ID will essentially give you every exam entry with the corresponding users, unless there is no user for that user ID, in which case it gives you a null. But then the where clause says, let's just get the ones with the null, because those are the ones we don't, that there's no user for, right? So this where clause says, we're just getting the users with the null, so the ones that are not in the users table, and then instead of selecting stuff, we just delete that. So we are deleting E, we are deleting the exam from the exam table. Okay, so the delete is running on the alias. Okay. These are very useful things to do on your own MyDB when you select something and later on you realize you were too inclusive, you want to delete something from it. Instead of running the big data query that takes for a day to run, you can just take your small table and just remove things that you don't need. Okay? All right, so the same way, and we can run this, and there's nothing. Okay, so maybe whoever is running it, because I think there were quite a few users that were not in the user statement before, but that's okay. So very similar to this is the update command that can let you change values in a table. Okay. So here we are updating the exam table and set the score to 10 for the user ID 13 and problem 1. So it's essentially the user, the student came to the supervisor and said, I want to retake that problem, and they do, and then the value is now updated with this command. Okay. Here the same story. You can have an update, set, from, join, where, everything. Okay. Everything that works in the select statement works in this as well. Now that said, if you are still debugging your code and your selection function, you shouldn't do the delete right away, because you might not be able to get back your data very easily. So you can always refine these updates and delete statements with select statements, and just in the end remove the select and then put in a delete or an update. Okay? Yes?
What's the difference between putting the semicolons on?
Oh no, so that's semicolon is just so just like in C, you can put semicolons. They have to put semicolons after lines. Here you can also do it. It's optional. There's one situation when you have multiple queries in one batch of executions. Then there are certain locations where you have to have semicolons, and especially before CTEs. Before CTEs, you have to have a semicolon. That's why. But for now, it's not relevant. If it's missing, it will tell you. If it's there, it doesn't hurt. So I think I just had it there because it looks pretty. I don't know. But you don't need it, so there's no need for that. Just like there's no need for the go or anything like that. Okay. So we'll just see if there's anything left in this table because it seems like it's very empty. Select star from exams. Again, just being lazy. Okay, there's still something in there. Good. So now comes the interesting question of how to figure out the grade for each user. So now we have everything, right? We have the score limits in the grades table, and we have the scores in the exams table for each problem. Was the query that assigns the grades to each student. I could let you work on that, but I think it's in the PDF file, so maybe I won't. I'll let you work on some other things later. Instead, I'll show you the query and then we walk through it. It's kind of an interesting query. Maybe I should write it from scratch, so that you, no, I'll just look at it. There we go. So first of all, this is the semicolon. First of all, it's a CTE to start with. All right, here we go. So as with such, we start with this query that's inside. What does it do, right? So the CTE user scores is nothing but the total score, the sum of all the scores on all the problems per user, right? So we are doing from exams group by user ID, select user ID sum score. Okay, so this will give you essentially the total score for each user, okay, or each student. So that CTE as user scores, we can use it later on. Okay. Now, the next thing we do is we define a new CTE right away. We may as well, right? So the comma there and the new name is just another CTE. It's called user max. May not be the best name for it, but let's see what it does. It takes essentially the user scores, the total score for each user, joins that with the grades on a special condition. It's not an equal thing, like the run ID equals run ID type of thing. But it says, give me all the entries where the total score, right, we call it total, the sum of the score is total. The total score is larger than the grade score limit. Okay. So at this point, when you just look at this two lines, we, for each user, figured out the maximum, the total score that they earned, and then join that with the grades table, which is an actual table with all the score limits. And if somebody has earned the maximum point, then there will be multiple entries, right, coming back from this join. From the grades table, it will be coming back with the A+, A minus, the B, the C. Everything will be above. The total will be everything above all the score limits, right? But we only want the top score, right? The top grade. So what is the top grade that score is worth? So we do group by on user ID and total, right? The reason why we do user ID and total, the same reason you have to have essentially a group by on everything that you list here. But it is just the user ID, right? Because there's a single total for every user ID. So we do a group by on the user ID and then get the maximum of the score limit. Right? So we are now, for each user, picking out all the grades for which the limit is below the total score, but among them we pick the top one, right? So this is essentially a grade that is just below the score that they earned. Can you see it? Okay, excellent. I like nodding. So essentially, if I just did select star from user max, which you can do, right? In fact, you can always test these things like this. You can just say select star from user scores, right, like that. And you can run this query. So it gives me essentially the total score for each student. It's like 15 earned 30 points. Awesome. Then we go back and we do the comma here, or like this, and then I can do the select star from user max. Right, so then if I run this, then we see what the user max is giving us. It's giving us essentially the user ID, the total score they made, and the limit of the largest score limit. Where is it here? The largest score limit that corresponds to the grade that they earned. Okay. So the only thing you have to do in the actual query part of the query is we simply just join this to get essentially everything we need. We want the username, we want the grade name, so A plus, something like that, and the total score. So username, total score, and then A plus or A minus or whatever the grade is. Right? So this one-page query is in a single go, right? In a single execution, will get us everything we need. It adds up all the scores in the exams table. It looks up the grade for it and brings together the information we want to display on the printout or whatever for the class, or maybe do an email or something to all these people. Okay. So Hollywood did really well, A plus, but everybody else is not so good. Okay. And if now somebody updates the exams table or something happens, fine, just run this query again automatically and just get the new score, the new grades, and so on. Yes.
Are there ways to protect against somebody inserting unreasonable values? So I imagine that you can protect against, like, you can't put in a character for an int. But for example, with the scores, if someone put in 999,000 or a negative score, can you detect that before having to search and then delete?
Yeah. So yeah, I mean, you can put various constraints on the tables that they have to obey, and then essentially at insert time, the engine will complain. But usually constraints do slow things down. So then on big data solutions, you not always put those constraints on. Instead, you're careful when you query it, right? So if you are worried that there is bad entries, or in case of Sloan where non-existent entries are replaced by -999 or something, then you just say value is larger than 0, or value the score is between 0 and 10. Right? And if something is, you can do a lot of things, but everything has to be within sort of reasonable limits. And one thing I will not talk about, but you could implement as well, is something called triggers. So you can define queries that run every time certain things happen with the database. Say every time somebody inserts something into a table, you could be running a piece of code that does something, emails you or checks the validity of the results or recomputes something. So you can define triggers that will, again, could do these things, but they cost. Any questions about grades and managing your own data? Yeah?
What if you have like a million students? How would you decide that?
If you had what, sir?
Like a million students, like a big number. You don't have to even, are you going to type each code? Or can you?
Oh, I see. So if you had many students and maybe a web server will insert automatically the scores for you into the table? Or what was the question?
How would you insert basically the into the table?
Well, the
There's
question is,
no one
how do you have the data in the first place? So if it were in a file, right, which is maybe the most likely scenario, if you were given a file with millions of entries, then there's different ways of doing it. So there are tools that do it for you automatically. Most databases come with a bulk insert facility. So essentially, it's a command that is like an insert command, except it's called bulk insert, and you specify the file, and you have to say what's in the file. These things typically are different from database to database. So that these are the bulk insert facilities tend to be not standard. So ingesting data efficiently can have its own subtlety. But I suspect that you typically will, well, I mean, the web pages that give you the database access tend to have those facilities for you, so you can upload the feeds files, you can upload CSV files, and they create that table for you automatically, so you don't have to do it. If you had installed your own database on your laptop or your home machine or your desktop, you will have to look for the tool that does a good job and does it fast enough. But yeah, the thing to Google for is bulk insert. And yeah, it's a very useful thing to have. Okay. All right. So now the question is, do I move? So it's 3 o'clock. What time is it? 2 o'clock or 3 o'clock? 2. Excellent. Whew. All right. So the next thing we will do is we briefly go through programming, how to create procedures and functions, and what their properties are. And then I think we will break for exercises. And then at the very end, maybe grab the screen again and talk about transactions a little bit. So it's a little bit of the back end and what the other magical things happen that we typically don't think about, but are there for us to save our ads. Oops. Okay. So grades. I'll just put these a little bit. All right, so I'm going to grab a bunch of code in one piece and then just go through it. So just to speed up things a little bit. All right, so again, we talked about variables a little bit. You can declare them, and again, this will be specific probably to different variants or flavors of SQL. You can set those values, so declare here this to_pi variable float, assign to it and select it. You can actually run this code and it will give you essentially a single entry. Again, ignore the go. Don't worry about it too much. Yeah, so that's how you work with the variables. The reason why I wanted to introduce this is because next we create functions, and of course the functions have parameters, right? And those are variables. So there's no way I can avoid talking about variables. So the functions, or user-defined functions, called UDFs. The very first one we'll look at is a scalar function. So you give it a parameter or more, and it gives you a single number. Right? So here it is. This one is in particular looking at the largest X value in the data table above a Y threshold. Okay, so I don't know what this means, but that's what it does. So here it is, create function max data X. It has one parameter, ymin. Again, at is just the way to signal this is a variable name, float is a type, and returns a single float as, and here the begin end essentially marks the body of the function, which is whatever you want to do, right? So you can have an internal variable x, it's nothing to start with, a null. And then you can do a from data y larger than y min. See, everything is parameterized. And then you say, I want order by x descending, pick the top one, and assign to the x variable that x that comes back. So this is a pretty cool trick. You can actually assign variables inside the query itself. In this particular case, I could have said, set at x equals 2, and then have a nested query that has a single scalar. But you could in principle have multiple assignments happening in a select statement as well. So this is an unusual way of using the select statement to assign variables. Okay, but it's a very powerful one. And then just return that. And if you create this function, you can call it as you expect it. It just becomes sort of part of your tool set, and you just do it like this, right? This is two separate calls to it. You can say max data x, x equals pi over 10. You can call that. So y equals pi, y min equals pi over 10, right? So this is again, the parameter that you're passing is the lowest y value, and whatever comes back is the largest x value for that selection. Is that? It's a contrived example. It's not a correct example in the sense that there is no true meaning to it or fundamental physics behind it, but it is a syntax.
Pi function or
Pi is a function, yes. So pi is a built-in function to give you the value of pi. That's right. Yes.
So,
No.
so here all of your variables are single values.
Yes.
Can you define them to be like their own row or column?
Yes. You can have table valued variables. You can have table valued functions as well.
And you define them the same way with the @ symbol?
Yeah. So I won't get into the table valued parameters. I'll show you how to write a table valued function where the function itself spits out a table. Next. But you can actually pass in as a parameter a table as well. You can declare a variable that is a table. But again, this is where Robert would probably stand up and say, but the MariaDB doesn't support that. So this is where the subtleties actually very quickly. All right. So this is how you use this scalar value function. You can use it in a where clause. You can use it in a join condition. You can use it in a select, anywhere you like, right? So this is now a function. It's there for you to use anywhere you like, in place of a scalar. Okay, so let's look at a table valued function, which is pretty interesting. Let me do one more example for you before we move on. I wanted to show you this one. So, like I said, you can put it in a select statement like this, for example, right? So here you could, for every y value in the data table with some constraints, you could get the max x, right? So this is now going through essentially select entries of the data table and using that y as a threshold and look at everything above it, right? So it's doing a lot of things, querying the data table twice in some special way. Okay, very simple, elegant syntax, yet it's doing a lot of interesting things behind it. Okay. So the reason why I was interesting. I can't remember how I attribute this. I'm looking at different files I gave you. Let me show you this because actually this is an important piece that I was there was a moment where I was very silent when we looked at data, but let me show you this. So we talked about how to insert into a table values that you have ready to go, maybe in a web page or in your application, values that you want to insert row by row. And you can do bulk insert to get big files into it. There's also the other scenario when you would like to load data from an existing table into a smaller table, right? So maybe you are creating the big table and creating a subset of that in some transformed way for your own for your own study. So for that, you create a table just like you did before. In this case, I'm going to call this table junk. Okay. And you give it a column name and a type, and not null is usually a good idea. And then you can have other things as well. You can say y int, or I don't know, I int, not null. So just like that, you can define the table ahead of time, and then you can say insert into junk, and say I don't know, round y. How about that? Something
Get
like
the
that.
typo there.
I do? Yes, thank you. Awesome. So you see here I created a table with an X and I column, and I can just create a data table which is potentially very big, and just grab some subset of it and insert it into the junk table. Now this may or may not run, but it does run, okay. The reason why I thought it may not run is because round potentially returns a float, and this is an int column. Even though it's an integer, it might have, but it was okay. Right, so now we just grabbed some random x and round y values and put it into a junk table, and I can use that table. Right, so everything that you learned about querying tables and joins and everything can go into here as long as it matches the definition of the table that you are inserting into. It's going to work. Okay. Okay, this is all I want to say about inserting data. And let's move on to table like variables. Yes, okay. Here it is then. Let's see the example quickly. Since you asked the question, I was going to jump through this, but so this is a table like variables. So here declare a tab is the name of this table like variable. The name of the variable is a tab, but the type of the variable is essentially all this, right? So you say it's a table, and you say what the columns are. And in this case, there's only one, the max x, which is a float, not null. But you can have multiple columns as well in here. This is now a table by variable, and you can, insert into this just the way you would do it otherwise. You can, if you can insert into a normal table, you can insert into a table by variable the same way. Now the thing is, that variable is only alive through execution, right? So if I were to run these separately, right? If I run this first line, that's fine, it succeeds, right? If I run the second line, it complains because there is no variable a tab, right? So I have to run them together, like this, right? And in this case, that table was created and it inserted some data into it. Except you don't get to see it, right? In fact, it's gone. So if you want to see it, you would have to run everything together like this, and then you get to see what's in that table. But this is how you create table-like variables, and you can use them. All right. So let's look at table values UDFs. So these are actually very important and very interesting. These are the functions that return a whole table for you. Okay, here's one that creates essentially the maximum x and data x. This is returning nothing but the largest x's above some y threshold. Okay, so the way it works is that you define the table up front, just like you would define a table, and then in the body of the query you insert into that table. It's essentially a table variable in a sense in the body of the function, and then you just return and return, of course, whatever is the returned table. All right, so any questions about this? Clear?
What does UDF stand for?
UDF, user-defined function. User-defined function, UDF. This is a table-valued UDF. The previous was a scalar-valued UDF. So you use this differently from the scalar-valued because this is used in place of a table as opposed to a scalar. So here, excellent. Somebody has done it. Thank you. So here you would do something like select star from DBO max and data x, and then y means 0 and n say 10. Right? So you can just run that, and it gives you the result. But now you can use this UDF anywhere where a table would go or a CT would go. Right? You can join with this. You can do a lot of things. Okay. You can drop functions and tables the same way. You just say drop function, drop table, and so on and so on. All right. So there's one more thing I wanted to show, and then I think I'm done with these procedures. Is user-defined functions, but the problem with these kinds is that they actually build the table in memory, and it's very inefficient when you're in big data sets. So it builds the table in memory, and when you issue the return command, it will actually return, like dump the table onto the engine. So there's a better way of writing certain type of queries or certain type of functions, especially the ones like this one where a single select statement is included. So I should say a couple of things about user-defined functions. So UDFs, by definition, cannot have side effects. So everything that they do will be returned in the return object, the table or the scalar. There's no other side effects can happen. If you create a store procedure, which we can do, then you can do multiple things, a bunch of things to the database. Here, there's nothing is happening besides returning whatever you're returning. But you could be, writing a very complicated whole set of queries and doing a bunch of things after each other and having variables and all that. In the case of not having the complexity, just a single query, there's something called an inline function, which on the other hand is very efficient because it practically becomes part of the optimizer. It's part of the query, and the optimizer treats the whole thing as one place, as one entity. And the way you define it is a little different, but otherwise it is the same. Here is the same version of the same function, but now an inline variant. So it says create function, the table name, and then the argument is the same way. But then instead of defining what the table is, just say it returns a table. Right? There's no definition of that table. There's no variable that is introduced for that table, except when instead of a begin end, you just have a single return, which contains a single select statement. Okay. There's plenty of things that can happen in a single query. You've seen single queries that do a lot of things, right? So that complexity here can be really, sky's the limit. But as long as it's a single query, it can be an inline function. This is very efficient because it will be treated as part of a query when you actually write a query and the optimizer figures out what to do with it. So there's no surprises. It works the same way. If you want to drop it, you drop it like this, drop function and the function name and so on and so on. Okay. There's one more thing that's worth mentioning, but I really don't want to hold you up for much longer. And that is about how you would apply a user-defined function that's table valued to a bunch of entries. I know this is now coffee time or something, right? Everybody is sort of sinking into the lunch. But this is the last thing I show you, and then you can go off and do your exercises again. So here the name of the game is, right? You created a piece of code that returns interesting measurements about something for a given parameter. But now you want to run this on a bunch of things. Okay? And that a bunch of things, of course, is coming from another table. Right? So this is a construct called a cross-apply. It's a very useful one that actually is used a lot by those who understand it, and you will be one who does in about 5 seconds. So here what happens is that we are creating the data table as before, but instead of doing an inner join now, which we could be doing with the table valued something, we are doing a cross-apply, which is just like a cross join, is giving us a bunch of combinations, right? So in this cross apply, we can pass anything from the data table as an argument. So in this case, we are passing the y value, and then this was the top 3 parameter, the n, and we call it f, so we can refer to it, and we are returning stuff from the data table, and then the result of this inline function for some subset of the data set. Okay, so what's going to happen is now every row that passes that where clause, there will be multiple rows in this result set that come from the function. In fact, 3. There should be 3 of them, because this 3 actually says there will be 3. Right? Remember, this function picks the largest x values that are above the threshold that you pass on the y. Right? So if you run this, let's do that, then you should be getting back 3 entries for each data point. So this is the data ID, the 3 is the same one. The y is the same, of course, as well, because it's the same entry. And then these are the top x values in some order. I would have thought that there is ordering in here, but maybe I have to say it explicitly. Let's just say it quickly. Why it's not ordered? Oh, because there's no ordering here. Okay, this was messed up, right? Order by what is it? X descending, right? So let's drop this function. Let's fix this bug. Oops, like that. Let's rerun this. All right, and then let's run this again. Okay, now they are probably right answer, and they are decreasing order. So you're getting the top 3 x's, 0.8, 0.76, 0.71, for every y that you're passing in. Okay, so this is a cross-apply. So for every row in the data table, you could get multiple rows. Say you wanted to look for the 3 closest objects to every galaxy, right? So you could be creating a galaxy table here, have a function that looks at all distances to the galaxies or other objects in the database, but get only the closest ones, the top 3 closest ones. And so this would be a way to get the closest 3 object to every galaxy, for example. Right, just one example. That's the kind of thing that you do. Okay, so I think that's where I stop. We have a break if that's a good time, and then
the break will be later, actually. So
the day. Okay, then there's no break. Then we just either stay here or move back to the round tables and pull up the PDF file. Have your copy if you want, and feel free to try any of these queries again, and then move on to the exercises and see if you can solve those.
So, sorry, first off, before we get up and move, I should ask, are there any questions following the material we just learned?
Yes, please.
Is this the last time we're going to be talking about SQL this session?
Yes.
Yes.
So after the exercise, I'll talk some more about things that you won't be practicing, or you will afterwards But yeah, you're welcome to ask the question right now.
So, let's say I have databases that
Yep.
I want to use SQL on. How do I import that data without saying like insert numbers or like anything like that? Like, I mean.
Same question as I had before. So this is the bulk insert. So there's depending on what database you'll be using. If you're using a database that has a web interface, just like the slow database does, there is a button for it, right? So on that page, there's a button that says upload data. And then you can give it a FITS file, you can give it a CSV file. It ingests it, and it will give you a table that's ready to go. If you have your own database installation, then the answer to your question depends on what database installation you have. Every one of these tools will come with a bulk insert facility or tool that will be able to load the data for you very quickly. So what you expect it to do is essentially provide a schema in the create statement format. So the create table and then the name and then and after everything else is automatic. You just press the button and the machine ingests the data. But how it's done will depend on the solution that you pick. Okay.
I have two questions. One is a simple one. How long will this toy database be sitting at Gwen 1?
It's last time I taught this course was a year ago in the spring, and I just realized it's been up all ever since. I won't take it off. This is something that might at some point go down. If you need it, let me know. That said, everything that is here, that we have done here can be done on Sci server, the Sky server, any of these functionality. If you want the data, is also a small amount of data. I can give you the data, but this will be also there. Just if it doesn't work, if you need it, let me know, and we'll fix it. But it won't be taken down, which is why I was hesitant to publish the URL to the whole world, because next time I teach this course, I intend to reuse that same URL, which I don't know when it's going to be, but you're welcome to use it, and yeah, feel free to play with it. There's a limit on the database. The database in size cannot grow bigger than 100 megabytes because it's a toy database. So you won't be able to put in big data sets. On the other hand, the data that's in there, you'll be able to play with, and you can create small tables next to it. Yeah.
And one more question. So suppose we've now done our query for this toy. I'm specifically talking about this toy database.
Mm-hmm.
We've done our query. We have our results. Is there an easy way to export those results to like a CSV file or something that
Right.
we can read into Python, say?
That's right. So Control C. So that's a very good question, and in fact, it would be nice to have a better functionality. Right now, essentially the easiest probably to do is just grab it. Maybe even Control A. No, let's do it like that, and just paste it. Just cut and paste it into something. It's not too big, which shouldn't be big, right? Because you want to write the query such that the result will be small. You don't want to transfer lots of data back to your computer usually. The whole point of writing sophisticated queries is that you can do everything remotely that's possibly doable, and get back only the small data sets, maybe a histogram or something like that. But once you have that, I think you can just, it's been a while I had this, did this, but I think you can just copy and paste it into, I don't know, probably an Excel, just Notepad or something, and it will be easy to plot with anything really. There's no built-in facility into the sandbox that would do this for you, but just try this for fun. So if I just do this, no, it doesn't work. So I can just cut and paste.
We can play with that.
Yeah, so this is something that you're on your own at this point, but it is really just for this presentation or introductory purposes. Okay, so I had one more thing. I think there's always one more thing, but I lost it. Here we go. So the procedure stuff. this is again something that is not so important, and it's less so again people don't always use it, and I just want for purpose of having everything sort of covered. Stored procedure is not a function; it's a user-defined procedure. You can use the create procedure command for it. You can do anything. So the flexibility of this procedure is that you can do anything in some of these things. You can have a bunch of commands. You can insert into tables. You can do updates, deletes, everything in procedures. If you can use user-defined functions, that said, these have their own purposes as well. So that's data management and programming. Please have a look at the handouts and have some fun with it. And then at the very end, just before my time's up, I'll grab the screen for another 5-10 minutes and talk about transactions a little bit so that you know the extra features that you're given if you use databases.
All right, let's thank Josh. Now I'm going to insist that once again everyone gets up with their laptops and moves to the table.